looking at this question, the first thing I see is I see the word solve. So this isn't a proof. We're allowed to move things from one side of the equation to the other. But when I look at what the equation looks like, initially I've never solved a question like this before. I look and I'm like, oh, there's a lot of cosines, there's a lot of sines, and it's equal to 1. Now the new formulas that we're learning that are on our formula sheet, they're on your formula sheet, but they're not very helpful unless you have them like semi-memorized. So you have to, in the middle of a question, go, hey, I think that's one of the formulas. That might trigger you to look at your formula sheet and say, yes, on my formula sheet I have that cos alpha minus beta is cos alpha cos beta plus sine alpha sine beta. And this part right here, if this is alpha and this is beta and this is alpha and this is beta, the left-hand side of that equation sure looks like this formula. So again, how these formulas work is whenever you have one side of the formula, you can change it to the other side. So very first step that I'm going to do is I'm going to take that and I'm going to write it as the left-hand side. Alpha was 4x and beta was x. And 4x minus x becomes cos 3x. And this looks a lot simpler than what we had originally. And we still have to solve this equation. Do you remember what we called this kind of equation? Do you recognize it? We gave this one a name. Multi-revolution. So sometimes if you remember the name, then that keys you in, oh yeah, I remember how to do that. A multi-revolution question, first of all, you rewrite the domain for 3x. So if you multiplied everything by 3, my domain would be between 0 and 6 pi. And then you solve for 3x over its domain. 3x would equal, well, is cos ever equal to 1 on your unit circle? Yes. At 0 and at 2 pi, that's once around. How many times are we going around? 3 times around. So second time around you'd have 4 pi. Third time around you'd have 6 pi. But there's no equal sign here. So we don't include the 6 pi. So 0, 2 pi, and 4 pi, and then we could solve for x by dividing each of them by 3. And we get x is 0, 2 pi over 3, and 4 pi over 3. So first way to recognize an identity. We don't know if that's going to help us, but we see what that looks like. Then the equation turned into a multi-revolution question. We solved from there, and then we were able to finish. So you'll often have questions take from a lot of things that we've learned so far and put them together. Okay, you can circle questions 15 and 17.